Okay, quartiles, which is one of our measures of spread that we look at. Basically, the idea is to break it into smaller parts, because looking at just range, it's not really that useful, other than tells you, okay, how wide is the data? It doesn't tell us a heck of a lot about the actual spread of the pieces of the data themselves. So we break it into smaller ones. In fact, why quartiles? You could, if you really wanted to, break it down to percentiles, which a lot of places do, but that's breaking it into 100 parts. It's basically telling you what percentage you're above, basically, isn't it? The 90th percentile would tell you you're in the top 10%, basically. Okay. Deciles are a bit more common when they tell you which 10% grouping that you're in, but then quartiles are something that we look at a lot, and that's when we just divide it into quarters, so the 4 parts. The first quartile is then the lower quarter, bottom 25%, if you like. Another name for it would be the 25th percentile, because it's covering those 25%. Second quartile, well, the median is where that boundary is. Third quartile then is the upper quartile, and that would be the same as the 75th percentile. We're using these measures, we can work out a better range known as the interquartile range, and that's when we talk about the middle 50% of the data. And the reason that's more useful is because if you get, say, some outliers, it can really exaggerate the range. But if you just look at that middle 50%, it can give you a better picture of the data. So you have your lowest score down there, which would go up to Q1, 25%, which would go up to the median, or Q2, which would then go up to Q3, and there's your interquartile range, and bring you up to the highest score altogether. Okay, so our interquartile range then is Q3 minus Q1, as opposed to the overall range, which would be highest minus lowest. Now, how do we calculate it? Depends on whether you got odd or even scores. So much like when you're working out what the median is, same thing. So here's one where we've got an odd number of scores. Again, we're placing them in order here. First of all, we work out the median, because if we've got an odd number of scores, then we've got a definite median. So Q2, or the median, we know where that is. That then divides the rest of the data into 2 even sets. In this case, they've both got 4 objects in them. And then we go and find the median of those 2 sets. Well, because there's 4, we then average, well, the average of 2 and 2 is 2, so Q1 will be 2, but then over in the right hand side we'd average 8 and 9, and we get 8.5. So our interquartile range then, subtract the 2, 6.5 for the interquartile range. Now, if we have an even number of scores, well, now we can just split them into 2 even sets. So we split it down the middle, and in this case we get 2 sets of 5. But again, we find the median of each of these sets. So the first one, 8, so that'll be Q1. In the second set of data, 11, that'll be Q3. Interquartile range is 3. And of course, if we did have to find that median, we know we average those 2 scores there, and that would get us 9.5. That brings us to this thing known as the 5-number summary, which are those important points in those quartiles. So the minimum score, Q1, the median, Q3, and the maximum. So for our ones that we just did, there would be our 5-number summaries. Now, just looking at numbers alone like that, yes, you could represent it like that, but it's much easier in a picture, which brings us to the box and whisker plots. Let's look at this example then of box and whisker plots, because what they're really good for is when you want to compare sets of data. So you can just look at the 2 plots together. So we've got 2 classes, results in a particular exam for that one. So this is a parallel box plot. That's because we've got 2 of them and they're drawn parallel to each other. But visually now we can get a good picture of how the 2 different groups performed. There's those points. So the lowest score, we put a vertical bar, higher score, vertical bar, Q2, vertical bar, Q1, vertical bar, Q3, vertical bar. So they've all got vertical bars. But then we box the interquartile range and then draw what we call a whisker. So a line out to those lowest and highest scores. But the problem with this one is the outliers. And there are a couple of results, you can see them here, look, 23 and 37. They're really pulling that range down. And I guess that's why range is not that great when you want to compare the data, but interquartile range is a bit better. But if those outliers are really, really different to the others, then we can tend to say, well, look, I'm not going to include them in the data because it's really giving us a bad interpretation. It's sort of really biasing the data, if you like. Now, how do we identify whether or not it's an outlier? Generally something like this. There are different rules, but we tend to go with something like this. More than 1.5 times the interquartile range from the endpoints of that interquartile range. Do you include them or don't you include them? Sometimes you will include them, sometimes you won't. So you really have to, I guess it just depends on what you're investigating as to whether you would or not. But if you're giving a report on your data, if you don't include them, then you would make a note in that. You'd say, well, I've excluded these for this reason or what have you. So there's class 2. In fact, those 2 scores ended up being outliers according to our rule. So if we remove the outliers, you can see the box and whisker plot there. It actually tells us those 2 classes, they're not as different as we originally thought. And originally you look at it and you go, oh my goodness, look at this lower quartile. But it's only because these 2 scores, actually the bulk of that lower quartile were actually closer to the other class's data itself. In fact, if you look at the stats on it, the red one, the average is 82.1 with a spread of 9.37. Now, originally with the outliers, that class's average is 72.1 and a really big spread. Well, we can see it's a very big spread. But once you take those 2 out, the average goes up to 76. Now, obviously it's less, we can see that from the data, it's going to be less, but not as much as originally thought. And then the spread comes in as well.